Welcome to the last video in this palleting and conveyor program writing. The last time, we wrote some set of instructions that were used to palletize boxes in synchronizations with the pallet conveyor and box conveyor respectively. In today's series, we will be writing the last set of instructions which will be used to energize the last set of conveyors in synchronization with the palletizer. In the same vein, we will also be incorporating some safety features. These features are also sometimes known as muting. Stay tuned. I will be starting off by creating another block called Downstream Conveyor. And the program will also be written in FBD. So basically, I will drag the and bit instructions. I will also need to align this sensor. So basically, it is when this sensor is active that the fully stacked pallet should roll out. I will rename it as Stack Pallet Space Sensor. This will be assigned here. And it will be in series with the stack counter. And will be further in series with the OR bit instruction. The conditions will be stack pallet space sensor memories, which is an internal memory. And it will be further in series with this sensor known as the reset sensor. All this will equal stack pallet spaced memories. Now let's put all these into perspective. When the base sensor is active and the stack count is reached, then the stack pallet's memories condition will be active. Now I will add a timer here. The input of the timer will be the stack pallet base sensor. And the output will be stack pallet with a timer, which is an internal memory. Now the pallet elevator moving. That is the contact that detects when the elevator is moving. It will be tagged to the and bit instruction. This will be in a normally close configuration. And in series with stack pallet with timer, and further in series with the stack count memories. This will equal to fully stacked pallet at discharge memories. This will be added to network 2 of pallet in feed block in just a moment. Here we'll have to do some manipulations here to accommodate the newly created memories. So OR bit instructions will be added in series with the AND bit instructions and further in series with the equal bit instruction. The internal memories that were created in the downstream conveyor blocks will be added here. And here we'll change this to local memories instead of at output memories. This will also be added here. While the height pallet sensor will be added here. And the result will equal to the pallet chain forward. So in a nutshell, what we just did is, when the empty pallet is at in feed, then the conveyor should roll in. And when the pallet is fully stacked and it is at the base, then the pallet should roll outward. Again, the reason why all these equal to the palletizer chain forward is because it all moves in the forward direction. And finally, the reason for the height pallet is that we don't want the block to be active when the pallet is at height. Perfect. I will also like to add another conveyor here. This conveyor will not be as long as the other ones. Now I will be adding this set of bit instructions here in network 4. The added blocks will be in series with these sets of equal bit instructions. Here the output command for the conveyor will be added. While it will reduce input bit of the this and bit instructions to 1. The machine sysrun will be added here.
Perfect, Andrea. From what you wrote, you want the downstream conveyor to be active only when the start button is triggered. Perfect.
So we'll drag all these I/O to the factory I/O drivers. I will also drag this block to OB1 for program calling. And we'll download these new program iterations to our PLC sim, and let's see. Oops. There is a mistake here. This contact was in a normally open format, so I will change it to normally close, and let's see. Now we are fine. Again, one needs to be a little bit careful when using FBD. Most especially when dealing with input contact. In ladder programming, it is a little bit easy, but here it is quite different.
Perfect, Andrea.
This reset is also in open condition too. Let's rerun the program again now that all the errors has been corrected.
Perfect, Andrea. Everything works fine now.
I will be creating another block for the downstream turn star. Here is where the instructions that will be used to control the turn star will be added. But before that, I will be adding another conveyor. The reason is because that it don't like the transfer between the palletizer and the conveyor. So I will also be adding the coil contact with the existing block as well. Now back to the turn star programming. The fully stacked pallet approach sensor will be tagged here. In the set of this flip-flop, while the reset of this flip-flop will be tagged to the front limit sensor of the turn star table. While the output of this flip will result in turntable 2 fully stacked. Now let's put network 1 into perspective. When this sensor senses the fully stacked pallet, the turn star will turn to receive the pallet. When the pallet reaches the front limit sensor, the turn star will turn to its initial position. I will be adding another sensor here. This will be used to put the turn star conveyor in a forward roll. I will add A and bit instruction. The allow stacked pallets in will be tagged here and in series with the turntable at 90°. And these and bit instructions will be terminated to the set of the flip-flop, while the reset will be tagged to the front limb sensor. The result of this set of instructions will all equal to the turntable at the forward roll.
Andrea. So basically in network 2. This set of instructions will be active as soon as the pallet reaches this sensor. The forward roll conveyor will be active, which will make the pallet to move inward, and the table must be at 90°. And when it reaches this sensor, it should stop. Perfect.
Again, in additions, the 90-degree limit is very key here because it acts as an interlock. That is, it is only at that position that the forward roll limit should be active. Another thing worth noting is that it will help the customer in terms of energy usage. Hence, the electric motor that is driving the conveyor will only be operational when the fully stacked pallet approaches the table.
In network 3, when the pallet is at the front limit, and the turntable is at its initial position, which is at 0 limit, then set will be active, which will be connected to the set of the flip-flop. while the reset of this flip will be tagged to this sensor called turn *2 rotate back sensor. And the output of this flip-flop will activate the backward roll contact of the motor. This causes the conveyor to rotate backward. Hence the pallet will move outward as a result, and when it reaches this sensor, the backward roll will stop. Again, this network here is also similar to network 2. I will drag this block to OB1 for program calling. And I will also drag this I/O to the factory I/O driver. Now let's see. Now the pallet rows out smoothly, and this conveyor type is a little bit more smooth as compared to the regular conveyor.
Perfect, Andrea. The icing on the cake is when the program you wrote has the ability to repeat itself. So basically, the process will wait after some time and the loop will be repeated. Just a carbon copy of what was described earlier on.
Perfect, Andrea. Just like what Hendrik said. The program you wrote can also be known as a closed control system. The box palletization. The box conveyor and pallet conveyor all working in synchronization. And it is repetitive. Perfect. However, something is missing here. Which is safety. In an industrial setting, safety is very key because machines only understand one language, and the language is the written command. However, there is always room for uncertainty. So basically, the machine designer that I had the pleasure of working with in the past has devised a perfect way of solving these safety issues. And one of the ways is through a system which is known as muting. And again, looking at these simulations set up here, the palleting area will pose more risk than the other part. So we will be adding a muting system here. Muting systems are used to distinguish between people and materials. And it has a huge benefit in health and safety compliance for companies that uses robotic and some other automated system. Muting is designed in such a way that it will allow the pack to move freely within the muting system, and while some parts or human trips will not be allowed. To make it sync further, let's set up the muting system. In the muting system, I will be adding some set of beam and receiver and sensor here. Muting light will also be added. This will indicate when muting is happening. And siren will be added too. These siren will be activated when the muting ray is tripped. And finally, I will also be adding a stack light that changes in respect to the muting activities. In order to achieve muting sensors are arranged in such a way that only a very particular combination of signals could be triggered by an incoming pallet, while sudden triggering of muting beam will result to an immediate machine stop if the sequence combination does not occur. Now let me explain muting using these schematics. You know when the pallet is coming. It will trigger this sensor. And because it is in normally closed configurations by default, the contact will be opened. And as a result, this coil will not be energized. Now when the pallet reaches the receiver, the normally closed contacts of the beam will be closed. But because the sensor is active too, hence this will not reach the coil, and then the same will happen when the pallet is leaving the beam. Basically, the sensor will always keep the network of instruction open. So in a nutshell, the pallet will trigger this sensor at the muting inlet. And it will also trigger the other sensor at the outlet. This is also applicable to the other muting system. Again, these activities should not be put in bypass mode in an industrial setting. This is only meant for knowledge sharing and fault finding. Now, so Andrea, I will be adding another block to your existing one here. This block will be called the muting block. And I will be writing this program using statement list programming. So all the beam rays will be in normally open contacts, while the reset button contact will be in normally closed contact. The results of all these sets of instructions will be in muting upward memories. This is an internal memory bit. The same will also be applicable to the downstream muting system. Now, network 3 is where the muting programming will be done. All the normally closed contact of the transmitter beam will be in series with a normally closed contact of this sensor. This will be latched by muting emergency memories, and in series with a normally closed contact of the reset. Now what we did was, if either of the sensors is activated with the muting beam, then the system will not be activated. However, when the beam is activated, the muting will be activated. However, the activated muting should only be reset using the reset button. This will also be repeated for the muting system downstream, because we are incorporating two muting systems. Hence there is a need to create local memories for the two systems. So in network 5, the output conditions of network 3 will be here, an equal muting emergency for upstream, which is emergency A. Like the output of network 4 will be in here, and it will equal muting emergency downstream, which for emergency B. Now in network 7, the combination of the output of network 5 and 6 and blinking bit M10.3 will equal to muting machine sysrun, which is M4.4. The contact of the sysrun can now be tagged to the box conveyor and pallet conveyor. In network 8, the output conditions of networks 3 and 4 will equal to oops. There is a problem here. It is not ideal to have the blinking contact with a muting machine sysrun, because the whole machine will start and stop at intervals, which is not good. So it should be tagged to the muting red light instead. While in network 8, the machine sysrun can be used here. So again, when the beam is tripped, the red light will blink. Likewise in network 2, this set of instructions will stop the whole system. So for the muting lighting, the output of network 5 will be the series of the two muting sensors upstream. This set of instructions will equal to the upstream lighting condition. In network 10, the output of network 6 will be in series with the two muting sensors at downstream, and this will equal to the muting downstream lighting. In network 11, The output of networks 9 and 10 will equal the muting stream lights, which are for muting indicator lights. I will be adding the reset button here. While for the siren, the bit address will be added to network 8, and also the reset button lighting. So when the network stops as a result of the beam tripped, then the siren will be active. Likewise the reset button lighting. In machine lighting conditions, we'll use the bit address of the reset button light, although I can use any of these outputs. So it is not cast in stone. So this will be in series with not, and it will equal to muting fine. This will be the green light on the palletizer when there are no muting issues. So we'll drag this block to OB1 for program calling, and I will also drag the I/O tag to the respective I/O address in the factory I/O drivers. And we'll download the new program iteration to our PLC sim, and let's see. Let me trigger the condition manually, be it at upstream and downstream. Everything works as it should. Now, let's monitor it with a pallet and pack. The muting work as it should when the pallet passes. Now let's manually trip the muting system. It works fine. And let me repeat the same at the downstream too. Everything is fine.
Well done, Laura. Perfect.
Well done, Laura. Perfect. Safety is very key. It is something that I have seen in many plants. Perfect.
Let me ask this question. All these outputs will be terminated to where?
Mostly to the contactors or relay, Andrea.
So basically, these represent the coils of either the contactors or the relay. Perfect. Overall, machines, or let's say robotics, are used to replace human activities. Hence it will freeze up time for more research work. Please check the description below for the URL link to all the software that was used. Also, a copy of the written program with the factory I/O setup is also provided. Now let's do a quick recap. We started off by setting up the simulator as per requirements. From there, we wrote some set of instructions which was used to control the upstream conveyor and turn star. Afterward, some set of instructions was written which was used to control the activities of box palletization with respect to the box conveyor and pallet conveyor. Finally, we ended off writing some set of instructions which was used to control the activities of the downstream conveyor and the muting system. Hope you have learned something new today. See you in the next one.